Hello class, Mr. Diaz here again. This is part 4 of your exponent rules. Here we're going to go cover part 4 right there of section 4.1. So we're going to take a look at a couple of the cousins that you have for the product and the quotient rule. So the first one being, and this is coming from the product family. So you share some familiarity with your product rule. So this is considered almost like your fifth exponent rule right there. Is what if you have a base raised to an exponent raised to another exponent? All right. So once again, what if you have a base raised to an exponent raised to another exponent? Well, the rule is quite simple. The rule states that if you have that situation, you're simply going to multiply the exponents. Once again, you're going to simply multiply those exponents. So they're giving you a couple of examples here. The first example here that they're giving you in letter A, you have x raised to the second, this raised to the third power. Now, why do we have this rule? Well, it is a shorthand form of what we would consider the traditional method. If we were to do it the traditional method, x raised to the second raised to the third, we would have to rewrite this as x raised to the second times x raised to the second times x raised to the second. In other words, we're expanding this. Eventually, we go back to our product rule, which our product rule states that if you have the same base, you add the exponents. So 2 plus 2 plus 2 will give you x raised to the 6. And that would be your answer. Now, that's too long to do this particular example. So, the way the rule works is you have x raised to the second raised to the third. The way it works is just simply saying, all right, since this is being raised to the third power, we could just simply multiply the exponents. 2 times 3, and this will be x raised to the 6. And that's really what the cousins are. Those are kind of the shorthand forms of your product family, and you're also going to have one for the quotient family. So that's one of the cousins in your product family right there. We do have another one, so this will be the sixth exponent rule that you have there. The sixth one right there is, what if you instead of having exponents, we have two different bases. So let's say you have a and b, and both of them are being raised to the same power. Well, in this particular example, what's going to happen is that you're going to distribute that exponent to each of these bases. Now, normally these bases won't be that by themselves. You're going to have to join this with that other rule that we had right there. So typically these two are going to work together, those two exponent rules. So for right now, it's just simply distributing the exponent. So this will be a raised to the m and b raised to the m. If these two had other exponents, then you would apply that exponent rule right there, which would have meant that you would multiply the exponents. So let's take a look at a couple of examples dealing with that one. So if you take a look at letter B right there, letter B, you have a raised to the 0, b raised to the third, and both of them are being raised to the fourth power. Now this is what I was telling you before. Normally these two exponent rules are going to work together. In this particular case, what we're going to do is we're going to distribute the fourth power to the a to the 0, and the same thing to b raised to the third. Remember what it states. If you have an exponent raised to another exponent, we multiply them. So in this particular case, we're going to have 4 times 0. This will be now a raised to the 0, which wouldn't change things, but it will change it for the b. If we distribute the 4 times the 3, this will be b raised to the 12. Now, once again, we have a raised to the 0. So we got to remember what that exponent rule represents. So at the very beginning, I told you that a raised to the 0 equals to 1. Well, guess what's going to happen here? A raised to the 0 will become 1. And let me go ahead and write it here. B to the 12, we keep it the same. So 1 times b to the 12 is simply just b to the 12. And that would be your answer right there. So you're going to see from this point on that you're going to go ahead and adopt some of the exponent rules that we've already discussed before. Let's try another one. If you take a look at letter C, let me write it down first. Same situation that we had before. You have 2x, y to the 3rd, and you're being raised to the 5th power. So you're going to distribute that 5 times the 2, times the x, and times the y. Remember, this is being raised to the 1st. Same thing for the 2. And if you want to put exponents to them, that's fine. Just so you know that you're going to have to multiply those. So, you're going to have 5 times 1, which will be 5. So it'll be this 2 raised to the 5th. Same thing with the x raised to the 4th. This will be now x to the 5th. And the same thing with the y. 5 times 3, y to the 15th. Then we're going to go ahead and multiply this, 2 raised to the 5th. So remember, that's 2 times 2 times 2 times 2 times 2. So that will give you 32. X to the 5th, y to the 15th. And that would be your answer right there. So once again, 32, x to the 5th, y to the 15th. That would be your answer for that particular one. All right. So once again, those two rules come from the product family. You have one also for the quotient family, one cousin. And, well, technically the negative exponent could also be considered a cousin of those, but it's kind of separate. So for the quotient family, it's very similar to the one that we just did with the product family, where we have two different bases. So in this case, this will be number 7 here. And this will be a raised to the over b raised to the m power. So, just like we did in the previous one, we're going to distribute that exponent to the top and to the bottom. So this will be a raised to the m and b raised to the m. Now, once again, keep in mind that you're going to use that exponent rule with this exponent rule that we talked about as well. So you'll see a lot of intermingling between the exponent rules. So let's go ahead and take a look at an example of that. Take a look at letter D there in part 4. So letter D, we have negative 6 x over y raised to the 3rd, all of that being raised to the 3rd power. All right, so once again, we have several bases. In this case, we have the negative 6, we have this x, and we have the y to the third. Keep in mind that these are being raised to the third power. Now you got to be careful with this one because it has a negative to it, so we have to make sure that we include that. So this will be negative 6 raised to the third. Here, 3 times 1 is 3, so it'll be x to the third. And the same thing at the bottom. Y to the third times 3, that'll be y to the ninth. From there, we're going to go ahead and simplify this. More than likely, you're going to have to simplify from this point on. So don't leave your bases, your numeric bases like that. Negative 6 raised to the third power is negative 6 times negative 6 times negative 6, which will give you negative 216. So once again, you end up with negative 2/16 x to the third, y to the ninth. All right, so that concludes part 4 of section 4.1. In a minute, we'll take a look at part 5.